All right, the start of trig. We're going to start out with the vocabulary. Hopefully you remember a little bit about last year. You guys would have done angles on a coordinate plane. And the first vocabulary word would be, I put IS over here, but it stands for initial side. Initial means the starting point. So that's where we always start for our angles. That's why on your unit circle, most of you had 0 degrees there. 0 degrees. And then we rotate a ray. The center is at the origin. We rotate it, and we get to a new side, and we call this side the terminal side. So the terminal side is the side that stops to form that angle. So we got initial side and terminal side. You'll notice that I'm taking this angle and I'm rotating it counterclockwise. Going counterclockwise. And if we have a positive angle, it will be going counterclockwise. If I have a negative angle, the only thing that the negative does is tell you to go clockwise instead. So an angle that might be down here would be a negative angle. So if we start at the initial side and go the other direction, that would be negative. At some point you have to say the quadrants, like what quadrant is 45 degrees in? Do you guys know the answer? First quadrant, yeah. But when we write it, we do Roman numerals. So this is the first quadrant here. Second quadrant goes counterclockwise. Third quadrant. And then the fourth quadrant. We go counterclockwise. And I'm sure you are aware that a circle has 360 degrees all the way around. So in that unit circle where you had 0 degrees, right underneath it, you should have 360 degrees because all the way around is 360. And then if we talk about that being in radians, it has to do with the circumference of the circle all the way around. Talk about it being in radians, it's 2 pi. And we are going to do more with radians this year than we will be doing with degrees. So we need to start learning radians, and that's what we're going to spend the next couple minutes on. This says 2 pi radians, and it also says 6.2 radians, 28 radians. Where am I getting that number from? Do I know? Yeah. 3.14 by 2. And what's 3.14? Pi. So if we do 2 pi, we're doing 2 times 3.14. It's not exact. It's approximately 6.28. All right, so why are they called radians? What is a radian? What is a radian? This is a quick little video. It's actually not quick. This is a long video. You'll see what I'm talking about in a second. And if you had me or Miss B last year, you've already seen this video. That doesn't mean you remember it, so let's watch it again. What is a radian? Oops, I forgot. It's already good. Do you remember seeing the video? So anyway, before I get started, from the center of the circle out to this edge of the circle right here where I'm pointing, what is that called? It's the radius of the circle. They're going to take this radius, and they're going to take this measurement, and they're going to take it around the circle. They're going to take one radii and go around the circle. There we go. See, radius, it's going around the circle eventually. Takes a little bit of time. Can I pause it? Okay, real fast. You see how they put an angle there? And I tried to pause it when it said it, but I wasn't fast enough. You see that angle there? That angle is called 1 radian. 1 radian. Because the arc length is 1 radius. So the angle, the central angle, is 1 radian. Now they're taking that radius and they're just sliding it along. Now they're moving the angle. Yes. Okay, so now they have a larger angle, and this time the angle is 2 radians. This angle is 2 radians. Why? Because the arc length is 2 radii long. And what's that funny shape? Theta. And that's just how we're going to represent the angle at a higher level. We're going to call it theta. But not. Told you it's kind of long. We have 3 radii. Don't worry, we're not going to watch the whole thing. Okay, so now the central angle is how big? 3 radians. How much more to get to
80?
Yeah, 180 degrees. How much more?
50.
Huh? 0.14-ish. 0.14159, right? Why? Because from here to here is how far? Pi. Right? The whole thing is 2 pi. So halfway around is pi. So 1, 2, this is 3 radians. When we get to here is 3.14 radians, which is pi. Whole thing is 2 pi. I'm going to fast forward now. Well, they sound like they're having more fun than us.
You play music?
Maybe. I have planned it. All right. Let's just start here where they're at the very end. Okay. So here's an arc length of 6 radii. What's the angle going to be? Quick, before they say it. What's it going to be? 6 radians. 6 radians does not go all the way around. How much till we go all the way around?
0.28.
2.28 more, 6.28 all the way around. Can you see why? Because here's 6 radians, so 6.28 is all the way around, which is 2 pi. And most of the time we're going to leave it in pi form because it's more exact. But occasionally we might use it just like 6 radians. Good? So you guys on your paper you have this picture drawn for you. So if you are asked questions like, what quadrant is 4 radians in? You might want to look at this picture. What quadrant is 4 radians in? Third. Could I figure that out maybe without having the picture? Where is 3.14 radians? Well, it's not in a quadrant, but where is it? On that negative x-axis. So if I'm asking you where is 4 radians, then you would know, well, it's got to be a little bit past 3.14, right? So you could kind of figure it out that way. Okay, but then the next section is for exact radians. And this is where the unit circle, we would use the unit circle. Okay? But I'm going to show you how I would get the exact radians, because I don't just straight up memorize the unit circle, because then you can only answer questions about the unit circle. I'm going to show you a way that I would get the radians so I can answer a question about other radians that are not on the unit circle also. Okay? So I'm going to start here with this graph, and we know all the way around is how far in radians, exact radians. 2 pi. All the way around is 2 pi. So that means halfway around the circle is pi. So you need to know that for sure. And most of these, I'm going to look at it and compare it to just halfway around the circle. Most of these, I always look at it as being halfway around the circle, which is just to pi. And in the top half of the circle, when I go to find that angle in radians, I'm looking at what I did to pi. I took pi and I drew one line down the middle of pi. I took pi and I divided it into how many places? 2. So right here, this is pi divided by 2. Because I took pi, the top half, and I divided it into 2. So if I took the top half and I divided it a little bit more, how many sections did I take the top half of pi and divide it into? 4. So this very first one, oops. Hold on, technical difficulties. I decided to move. Okay, so if I took this very first one right here, I divided the top half by 4, then this one's going to be the top half, which is pi, divided by 4. That's the first one. And then if I start at the beginning and I go 2 of these sections, 1, 2, then I've got 2 pi over 4s. 1 pi over 4, 2 pi over 4s. Which is pi over 2. And if I took this pi over 4 and I went 3 sections, pi over 4, pi over 4, pi over 4, that's 3 pi over 4s. And if I went 4 sections, 1, 2, 3, 4, if I did 4 pi over 4s, what does that reduce to? Pi. But I already know that was pi. But I keep counting because sometimes we want to go past pi. So if I keep counting and I keep dividing this up by the same measurement, and I go to this one here, how many pi over 4s is that one? 5 pi over 4. And I keep going, and my next one is 6 pi over 4. But that's not what we call that one, because it reduces. What do we call this one at the bottom? 3 pi over 2. And I keep counting, and I do the next one. That is 7 pi over 4. And I could keep counting, and I would have 8 pi over 4. But that reduces to 2 pi, so we would call it 2 pi. If it does reduce, we will reduce it. But what I did was I knew the bottom was 4. I divided the top into 4 equal sections, and then I counted 1 of them, 2 of them, 3 of them, 4 of them. Okay? Let's do it again. Let's divide it up by a different amount. Let's use a different picture. Let's choose a different one that you have there. So things I know right now is this is 2 pi, or 0. It's also 0. And this is pi. Now this time I'm going to take the top half, the pi, and I'm going to divide it into 3 equal sections. But I'm not quite sure where to draw my lines, so I might think about it in degrees just for a moment. Let's see, this one is how many degrees? Pi is how many degrees? 180. If I divide that into 3 equal sections, each one is how much? 60 degrees. So I'm going to kind of approximate a 60-degree angle here. And then I'm going to approximate another 60-degree angle, but that would be 120. So when I divide it into 3, it does not go on that 90 degree. Right? We're counting by 60s. 90 is not divisible by 60. So then I go to find the radian. I took the top half and I divide it into how many equal sections? 3. So this first line is the whole pi, that top half, divided it by 3. top half divided by third. What is my second section? 2 pi third. 2 pi over 3. My third one would be 3 pi over 3, which is pi. But eventually we might need it as 3 pi over 3. We might need it as that. So I'm just going through it and saying it. And if I want to go around and I want to label more, then I have to keep counting by pi over 3s, which is like a 60 degrees. So I'm going to draw another one. This one's going to be my 4 pi over 3. Will my next one be on the y-axis? No, because we're counting by 60s and there's only like 30 left there. So it's going to be 30 past it. That one's going to be the 5th pi over 3. And the last one will be 6 pi over 3, which has to equal 2 pi when I reduce it. Where would 7 pi over 3 be? It would be one more, and it would be the same as pi over 3. And if they're the same, those are called coterminal. We're going to do that in a moment. Okay, so these are the pi over 3s. The 60-degree angles are the pi over 3s. By the way, I didn't say this earlier. I'm going to go back and say it. What angle was the pi over 4? If you take 180 and you divide it by 45, you get, divide by 4. You get 45 degrees, okay. So the pi over 4s are the 45-degree angles. The pi over 4s are the 45s. The pi over 3s are the 60s. The next one. Let's take the top half. You know what I want to divide it by already? 6. So this is going to be 0 or 2 pi. This one will be pi. I'm going to divide the top half into 6 equal sections. If I need to know what that is degree-wise so I can draw better lines, what is 180 divided by 6? We're doing 30 degree angles. So will I draw a line on top of that y-axis? Well, I'm going to. I mean, that is one of my divisions right there, right? So if we have the top half, which is pi, and we divide it by 6, we now have pi divided by 6 as my first one. So pi divided by 6 is 30. Pi divided by 3 is 60. Pi divided by 3 is bigger chunks than pi divided by 6. Smaller chunks. Okay. So what's my second one going to be?
2 pi over 6.
2 pi over 6, but that reduces.
Yeah.
And then my third one is going to be 3 pi over 6, but that reduces. And then my fourth one is going to be 4 pi over 6. That reduces. My fifth one is going to be 5 pi over 6. That one does not reduce. 6 is going to be 6 pi over 6. What if I have to keep going? So I'll have 7 pi over 6, 8 pi over 6, which reduces. 9 pi over 6, that reduces. 10 pi over 6, reduces. And then 11 pi over 6 does not reduce. All right, doing okay? Any of this stuff coming back?
Yeah.
Are any of you filling out your unit circle at all? You don't have to right now, but like I've done every angle on the unit circle now. Well, we're going to keep going. We're going to get through these notes, and then you'll have the rest of time to work on your matrix review. If you get done with that, you can work ahead on the fun stuff. Huh? Okay, we'll do a game after this. Maybe we'll talk in this thing. We'll see. All right, so example 1, we need to sketch an angle in standard position and find the measure of the angle in degrees and radians. So this says we're going to do 1/3 rotation of the whole circle, 1/3, and a CC means counterclockwise. So go ahead and draw your, what's that first one called? The starting one. Initial side. And then we need to go 1/3 of the way around. So if I have, what's all the way around in degrees? 360? If I have 360 degrees and I want 1/3 of it, then I multiply 360 by 1/3. What do you, 1/20. Now, if you don't put a degree symbol, I think you mean radians. And they're very different. 120 radians is way different than 120 degrees. So make sure if you're talking degrees, there's a degree symbol. So we want to draw our terminal side at 120 degrees. Then you want to show which way you rotated with an arc and an arrow in the middle, showing which way you went. Because I could go the other way and end up in the same place. Those would be coterminal angles. All right, now we need to know radians. If you have it memorized, you might be able to look at this and know. But if you don't have it memorized yet, how many radians are in the whole circle? 2 pi. And we take 1/3 of that. How many radians is just this part? 2 pi over 3. Next, 7/4 rotation, and then what's C mean? Clockwise. So we're going to go the other way. Go ahead and draw your initial side, and then I'm not sure how many degrees I need to go, so I'll find the degrees first. I'll do 360 degrees, and I want to take 7/4 of that number. So you multiply 360 times 7 divided by 4, or take 360 divided by 4 and multiply by 7. You get 630 degrees. And how much is it in one rotation? In one rotation is 360. So how much further am I going? But which direction am I going? So the answer is not 630. Because I'm going clockwise. And what did we say about angles that go clockwise?
Negative.
Negative. So the answer is really negative 630 degrees for the angle. I'm going to draw it. Go all the way around once, and then go 270 degrees more. So I put an arrow that shows the direction that I traveled, that I rotated. And then make sure you have that negative if you are going the other way. And we need to do radians. I'm going to put it up here. So we're going to take 2 pi, multiply it by 7/4. 14 pi over 4, which is 7 pi over 2. Is that my radians? Negative 7 pi over 2 is the correct answer. So we're going the other way. Next section. Find one negative and one positive coterminal angle. So I was using this word a couple moments ago. Coterminal would be an angle that is here, but not negative 630 degrees. Can anybody look at this and tell me another angle that is the same place, but it's not negative 630? 90 degrees. 90 degrees? Yeah, that is called coterminal. It has the exact same terminal side. You just maybe got there a different way. So here, we're going to find one positive and one negative coterminal angle for each of these. For it to be coterminal, it needs to be at 30 degrees, but it can't be 30 degrees. So to get to 30 degrees, but not 30 degrees, not radial. It's going to be a degree form still. But instead of going like to 30 degrees, I can go all the way around once and then to 30 degrees. How much did I add to go all the way around and then 30 degrees? I'm adding 360 to it. I could also go, start it at 0, go the other way to 30 degrees. Whatever you do, it's always adding or subtracting multiples of 360. So to find coterminal, we either add 360 or we subtract 360. And there I have one positive and one negative. If it's given to you in degree form, you give the answer in degree form. If it's given to you in radian form, like E, then we give the answer in radian form. So I'll go to E next. Why not? E is pi over 3. So I'm not going to add 360 to pi over 3. What am I going to add instead?
2 pi.
2 pi. So I'm going to take pi over 3, I'm going to add 2 pi. Oh no. These are not like terms currently. We have to add with like terms.
6 pi.
Yeah, what are you doing, Nathan? Common denominator when we have fractions. So I'm going to change 2 pi into 6 pi over 3. So now I have pi over 3 plus 6 pi over 3. So my positive angle is 7 pi over 3. And then we also need a negative angle, so I'm going to take pi over 3 and I'm going to subtract 2 pi, but I'm not going to subtract 2 pi, I'm going to subtract 6 pi over 3. Negative 5 pi over 3. So one positive and one negative, those are coterminal. They have the same terminal side. Can you try F? Please, on your own, try F. I looked at it for a second, I'm like, oh, you have the same thing I have. Try F. Try F. Let's see. Okay, so if I'm adding 2 pi, I'm really going to have to add common denominator. What's it going to be? What's 2 pi with a denominator of 4? 8 pi. So 5 pi over 4. Yep. And then subtracting. Negative 11 pi over 4. Questions? Quick break. Question? We'll pause it. So in the assignment, you're going to see some questions that look like this. 25 degrees, 15, and then there's apostrophe, and 14 or 45, and then there's like a quotation. And those are read like 15 or 25 degrees, 15 minutes, and 45 seconds. And what minutes and seconds are is they're like a fraction of a degree. But it's not in our like normal base 10 where we have 0.5, which would be 5 tenths. It's in a different base. And the base would be like 60s. So minutes are each 1/60th of a degree. It's really small. And seconds would be 1/3600th of a degree. So like really, really teeny tiny part. Seconds are like 1/60th of a minute. So to do this by hand, we would need to take the 15 and put it over 60 and find that decimal, and then we'd have to take 45 and put it over 3,600 and find that decimal and add them all together. We're not going to do it by hand, though. We're going to do it on the calculator. The calculator will do it for you. But this is what the calculator is doing. So it says use the calculator to convert from DMS mode, degrees, minutes, seconds, to decimal. So we're going to get this decimal on our calculator. So everybody go to your calculator and just type in 25 to start. I'm going to grab mine and do it on here. Just type in 25 to start. Okay, and then there's this button that says angle. Do you see it? Second apps. That's the angle button. That's where we're going to find most of the stuff. So if you go to second apps, you see that one is a degree symbol. So type that in. And then the next number is 15 minutes. So if you go 15 and then you go back to the angle button, the minutes is number 2. So you type that in. Then we type in 45, but for some reason, and I don't know why, the seconds, the quotation mark's not under angle. But it is alpha plus sign. You see it above the plus sign? It's alpha plus sign. And once you have that typed in, hit enter. And then that's the decimal version. So you could have the decimal version and do whatever calculations you needed to with the decimal. Okay? And then we might need our answer to be put back in degrees, minutes, and seconds. So I have another example here. I don't remember the number. It's 99 something. It says convert 99.025 to degrees, minutes, and seconds. So go ahead and type in 99.025 on your calculator. And then go back to that angle button, and you'll see the button that says convert to DMS, number 4, convert to DMS. And once you hit enter, it will tell you in degrees, minutes, and seconds what that decimal is. Okay, when you're ready to go on, turn your page. So there's some questions that look like those, and that's how you convert back and forth. In which quadrant is the given angle found? And then it also says sketch your graph. We'll do it really fast. When it says sketch, it doesn't have to be perfect. 110 degrees. I probably went too far on that one. When you sketch it, make sure you show the angle, which shows which way you rotated it. Second quadrant, write it in Roman numerals. About 240 degrees and 30 minutes. So 30 minutes is a fraction of a degree. It's part of a degree. Is that going to make us go to a whole new quadrant? So 240 is past 180, but not to 270 yet. Somewhere in this quadrant, third quadrant. Negative 350 degrees. So we go which direction? Clockwise. And negative 360 would be all the way around, so we're almost all the way around. That's just my phone saying it's going to rain or something. And that would be the first quadrant. The next one is radians, but it's not one of the radians that we went over earlier. So this is where I'm going to use what we went over earlier and just figure out where 7 pi over 8 is really quickly. So we know that this is pi. And 7 pi over 8 means I am dividing the pi by what? 8. The bottom number is what I'm dividing by. So I'm taking this top half and dividing it into 8 equal sections, approximately. don't know what you're seeing, start from the 2 and go down. Oh, yes, yes, but not everybody gets that. I know you get it, and you can totally do that. So if I take the top half and I divide it into 8 equal sections, how many of them am I going through? 7 of them. What quadrant is that in? 2. How many of those divisions would it be to make it all the way to pi? It would be 8 of them. So we know this is what you were just saying. It's just a little bit above pi. I'm going to skip E. Just go to F. So F says -5 radians. So I know it's radian form, but there's no pi. So if it's in radian form, but there's no pi, the pi's already multiplied in it. So where is negative? What is this in radian form? All the way around. I just went negative. What is that in radian form? How far is that? -6.28. -2 pi. So where would -5 be? Not quite that far. Maybe about there. First question. Okay. You just gotta be careful. That's where people struggle, is when it's a decimal and the pi is multiplied in, because that we don't even use that much, but we use it occasionally. All right. I think it's. Oh no, it's not the last section. Almost the last section. You guys remember complementary and supplementary? Yeah. What do 2 angles add up to be if they're complementary? 90 degrees. And what about if they're supplementary? But these aren't in degree form. They're in radian form. So the complementary, their sum is 90 degrees, which is pi over 2. And supplementary is 90 degrees, 180 degrees, which is pi. So if you need to find complementary or supplementary, we want to take the total, the pi over 2 for complementary. We want to take the total amount, and we want to subtract off the amount they gave us. And whatever we have left over would be its complement. You take the total, subtract off the part you're given, and you'll have the complement left over. But I need like terms to subtract are these like terms. Now they do not have a common denominator, which should be my common denominator. 10. So I'm going to multiply this one by 5 over 5, multiply that one by 2 over 2. 5 pi over 10 minus 4 pi over 10. So my complement is pi over 10. Supplement. Same procedure. This time we start with pi, and we subtract off what we have, 2 pi over 5. Again, they have to be like terms to do subtraction. Right now they don't have like terms, so we have to make pi 5 pi over 5. So I get 3 pi over 5. So the next example, the complementary, what do we start with? Complementary angles add up to be what amount? Pi over 2. So we're going to start with pi over 2. We're going to subtract 4 pi over 5. We need a common denominator, so I'm going to make them 10. So I have 5 pi over 10 minus 8 pi over 10. I get negative 3 pi over 10. But in order to be complementary, you can't use negative. So this original angle they gave us, 4 pi over 5, was already over 90 degrees. If you get a negative answer, then there's no complement. There's no complement. You might have been able to tell beforehand, hey, this is more than halfway. It's more than 90 degrees. But if not, if you get a negative answer, there's no complement. And then the supplement, pi minus 4 pi over 5, which is 5 pi over 5 minus 4 pi over 5 pi over 5. All right, last stuff. Converting from degree to radians or radians to degrees. You would have done this before. When you convert to radians, if you start with degrees, and if you guys are in physics, I know you've done this already, you want to make the units cancel, right? Have you done that in physics? Wait, no. Have you done that in physics where you make the units cancel? So that's what I'm doing. Taking 135 degrees, and I'm going to multiply it by something that makes my units cancel. So my degrees has to be on the bottom. That's how I know which I'm using. If I'm using pi over 180 or 180 over pi, I want my units to cancel. So here my degrees will cancel. I'll get 135 pi over 180, and the answer should be in fraction notation. So I'm just going to reduce this, and it's 3 pi over 4. And that would be radian form. Hold on one second. Sometimes we could write in radian if you're really thinking about your units. And we are going to do a section next quarter that we really have to think about units. So sometimes I'll write radian in there so you can see the radian doesn't cancel. That was your question. So 540 degrees, 540 degrees, I'm going to multiply by pi over 180 degrees. And the pi is in radian form. So that my degrees will cancel. Then we reduce that one ends up being 3 pi radian. Okay, I'm going to go to the next section. I have that one filled in online if you want to go back and see it. So the next one's negative pi over 2, and we're converting from radians to degrees, so this is currently radian. So in order to cancel out radian, I have to multiply by radian on the bottom. So I'll put my degrees on the top. I want to cancel the radians, and my pi's will cancel. And reduce, we'll get negative 90 degrees. And just look at C. You can see C is in radian form, but that's the decimal radian form. So we're going to multiply by something that'll cancel radians. I'm going to have to multiply by 180 degrees over pi radians so that my radians will cancel, but the pi does not cancel this time. So we'll get 360 over pi degrees. And for that one, I would probably type it in my calculator and approximate it. Because normally we don't say degrees as 360 over pi. I wouldn't be able to graph it. You guys know there's a pi button on your calculator, right? Do not type in 3.14. So I get 114.59 degrees, and it's approximately. So I'm going to put the assignment up for just a moment, but I'm not going to leave it up. It is written on Canvas. It's written over there, but it's really small. I'm just putting it up so that it's on the video on Canvas. And then you really want to spend the rest of your time working on the review assignment for your matrix quiz. So I'm just putting this up just in case anybody actually watches my video. All 2 of you.